Okay, welcome to EGR 598, Applied Linear Algebra for Engineers. And I would encourage you, if you have not done already, please visit the Canvas website, wherein the syllabus is uploaded. My contact information is available. And you should be able to log in to Canvas, and you should take a look at the syllabus. The course is going to talk about linear algebra with robotic systems, data analysis, and machine learning. The textbook is the new textbook by Professor Strang, which is Linear Algebra and Learning from Data. This is one of the first books that actually took concepts from linear algebra and extended those to complex sensing, machine learning, randomized linear algebra, and optimization. So the concepts that are discussed in this textbook, they are super duper important and they are very applicable. But what I'm going to do is I'm going to go step by step and try to explain the concept. This book is a very dense book. There is lots of information, and it would be my job to make sure that information is presented to you in a very simplistic fashion. So what are we going to do in this class? We are going to have a lot of fun. So we are going to talk about linear algebra, fundamentals of linear algebra, and my understanding is most of you have had at least one course in linear algebra. You know what a linear algebra is? It's dealing with matrices. The unfortunate part with linear algebra course at undergraduate level is it lacks applications, and it does not have geometric interpretation, which is super duper important. It does not, we just deal with numbers, which are kind of, they are arranged in a rectangular or square fashion, and deal with these abstract concepts like eigenvalues, eigenvectors, but don't understand what they actually mean. What is the physics behind those numbers? When they are meaningful, what are the applications, and so on. So what I'm going to do is I will talk about how to add physics, geometry to the mathematical equations and the numbers that you see. So what we would do is we are going to start with something that you learned in high school. And we are going to start from that and build upon the concepts in linear algebra, and then we will advance those concepts to data science. Then we will advance those concepts to neural networks, machine learning, and artificial intelligence. And the beauty of it is everything is connected. So what we are going to talk about is starting from the first principles. We are going to all the way to neural networks and compressed sensing. So the fundamental purpose of this course is looking at applications. So what type of applications are we looking at? We are going to look at networks. We are going to look at graphs. We will try to solve networks. We will try to solve graphs. We will look at Kalman filters. We will look at particle swarm optimization, and so on. And believe you me, that they start with a very simple, basic understanding of matrices. So if you look at the syllabus, I would like to be upfront and very systematic about the course. So here is the grading scheme. 90 and above gets you an A. You do not have a final exam or a midterm exam. What you have is you have just assignments. And some of those assignments are group assignments. Some of those assignments are individual assignments. And some of those assignments are super simple. And some of those assignments are very challenging. So I would encourage you to read through the syllabus. And then what I want to do is I want you to look at the topics. So this is my intention to cover the entire textbook. But here is what I'm going to do. There is a lot of theory in the textbook. But what I would do is I would try to give you hints on the proofs. I don't plan on deriving Eckhart theorem or any proofs, mathematical proofs. But what I would do is I will try to give you some geometric interpretation, understanding of that proof, and mostly we will look at application. So what is an SVD? What is singular value decomposition? Rather than giving you the proof about singular value decomposition, you will work out a problem in Matlab and see that with singular value decomposition, this very large image can be compressed to a very small image and still we maintain 90% of the information. So we are going to focus a lot on applications. Once again, Matlab is our tool of choice. These are all the lessons that we are going to cover. So first part is basically a review of linear algebra. Second part is the numerical linear algebra. And then we would gradually go on to the applications like Fourier transform. We will look at some statistics. We will look at a little bit of randomized linear algebra because that is becoming a big thing. We'll talk about linear programming, optimization, stochastic gradient descent, and then we will talk about the neural network and applications and sensor fusion. So this is the tentative plan, and we will try to cover as much material as we can. Now, what I want to show you here is please look at the modules. So if you go here, the entire course is online. Now, a word of caution. I would strongly recommend for you to buy this book because the problems are directly from the textbook. And some of those problems come from or are similar to the problems worked out in the textbook. I will try to work out as many problems as we can, but what I want you to do is these notes are like a cheat sheet. So basically, it's a 40-page summary of this entire book. So if you open the notes, that kind of gives you, boom, this is what you are going to study. This is the gist of the textbook. So these are the notes. These are the cheat sheets. And I have already uploaded the video lectures for part 1.0. So which is the section 1.0. So if you open up the textbook, the highlight of linear algebra, I have already added some video lectures. The emphasis of these video lectures is to give you the understanding of theory. This is the exact same course taught at MIT by Professor Stein. And his video lectures are also available. As a matter of fact, if you go to the course website, that course is MIT 18065. His lectures, and they are beautiful. Those lectures are already online. But his teaching style is like mostly explaining and then giving problems to work out to the students. And I would like to actually, rather than just assigning you problems, I would like to work through the problems so that you understand how it is done. But because of the time constraint, I won't be able to spend the time that we should be spending with the theory. So I'm gonna make video lectures and upload these onto Canvas every week. And I would strongly recommend that you watch the video lectures when you study on the book. But I would expect that everyone to have a copy of the book. And once we are done talking about in the class, watch the video lectures, review the material. This material is super important because most of you are going to take classes in neural network, image processing, machine learning, artificial intelligence, maybe multiple robot or swarm robotics. All those things, they have their roots deep in linear algebra. But unfortunately, we fail to make that connection. So it's my job to make you aware of that connection. And once you understand the fundamentals, then it will all start making sense. The another thing which I just want to talk about is probably you had a linear algebra course before, but no one teaches the linear algebra course from a geometric perspective. Which means those numbers, they mean something. They mean a line or a point or a plane. So these are the review lectures on the basic linear algebra or matrix manipulation. Please watch these videos. You'll be amazed by the beauty of it. These lectures are completely cartoon animation. So I don't know if you have watched this. These are the lectures by 3 Blue 1 Brown, and he is a fantastic instructor who specializes in teaching complex concepts with cartoons. So he created. So I mean, you have to just watch these. What is vector? What is linear combination? Linear transformation? Matrix manipulation? 3D transformation? Determinant? Inverse? And each lesson is about 5 to 10 minutes, not much. So you can watch it while traveling in the bus or shuttle, or you can watch it if you are waiting for the class, or you can just watch it when I'm setting my setup or machine. So you can watch it over the phone, or you can watch it on the computer, and you will gain so much information that then what we discuss, it will all start making sense to you. So everything that you studied, eigenvalues, eigenvectors, eigencomposition. So these lectures, I wish I could teach like this, but unfortunately, I don't have the resources for a digitized glass screen where the animations can pop up and actually I can show it's not just possible. Each and every lecture, each and every lesson in here, it took about days to create. So please watch these. All these resources are compiled and available for you. Then there are lessons on graph theory, compressed sensing, sparse matrices, Fourier analysis, digital Fourier transform, stochastic gradient, clustering. All these lessons are visual. So you will see cartoons, you will see things flashing at you, you will see how those things come together and so on. So please make use of those resources. Then next thing I want to talk about is assignments. All the assignments are already posted on Canvas. There are no final exams, no midterm exams. All the assignments are take home. As a matter of fact, attendance is not even compulsory. You are welcome to attend the lecture online, or you can attend the lecture asynchronously whenever you want. But please make sure that you turn in your assignments on time. So The first assignment is due on August 31st. And since we are going to use Matlab heavily in this class, same drill. Download and install Matlab, create self-paced courses. But the good news, if you are in the robotics class and if you do the Matlab fundamental class, you can double dip. You can take the same certificate and upload it for this class. So that way, if you are in robotics class and if you are in linear algebra class, your first part of assignment is the same. As a matter of fact, second part is also the same. So once you finish this, you are going to get a certificate that you upload. Third part is the same, but the fourth part is different. Fourth part is introduction to linear algebra with Matlab. How do you solve linear algebra problems? And these are not very advanced problems. The simple problems. How to solve linear systems of equations, how to solve eigenvalues, eigenvectors, how to convert matrix into a Jordan form, and so on. Those simple problems, how do you solve those problems in linear algebra using Matlab? So again, at the end of the courses, you are going to get a shiny certificate. You are welcome to put it on your LinkedIn website. And let me talk about the second assignment. So first assignment is super simple. From second assignment onwards, things are going to be little bit challenging. So in the second assignment, again, what I'm asking you to do is, now you will have to do the on-ramp for the signal processing, SimScape, state flow, and control design. So first two assignments, I don't see any reason we should not be able to get full points. So do those courses, get those certificates, upload, and you'll get full points in the first two assignments. So that is super simple. However, as soon as the third assignment starts, we would have, by third assignment, we would have finished significant chunk of the material from the first part, which is the basics of linear algebra. And these are the problems from the end of the book. So if you go to the textbook, these are the problems. Problem 10 from page 7, problem 11 from page 7, problem 5, page 13. Some of these problems are just fill in the blanks. So if you read the relevant section from the textbook, you can finish that part. But some problems, you really have to scratch your head to get to the solution. But every point, every problem, big or small, is worth 1 point. So as long as you do most of these, you should be okay. But I would caution you that assignment number 3, some problems will be very frustrating. Assignment number 4, same stuff. But in assignment number 4, again, some problems would be very frustrating. Some problems are super simple. So as long as you do most of these problems, you get them right, you should be good. And my hope is that once you turn in the assignments, I would be able to solve some of the difficult problems in class that will give you, I worked out the solutions already, so I can share the solutions with you. And assignment number 5, again, same thing. By assignment 5, you would have covered about 75% of the book. So assignment number 6, again, what we have is, by the time we would have discussed the theory behind optimization, what I want you to do is, I want you to do the optimization on-ramp. And by the time you would have finished basic statistics and randomized linear algebra, so I want you to complete the course on statistical methods with Matlab. So, and the last assignment is assignment 7. And assignment 7 is actually gonna ask you to do the machine learning, deep learning, and reinforcement learning courses on Matlab. So if you look at this course, basically getting an A grade is very easy. So don't wait for the deadline. Just finish off assignment number 7, assignment number 6, all these courses. That way, when you are busy with other assignments of other classes, you don't have to worry about doing these classes and courses. So you can actually pace yourself. Can we use? Yes, you are welcome to use Matlab to verify the problems. But some problems are theory problems, and but you are certainly welcome to use Matlab. And I would, when I discuss from next class onwards, what I'm going to do is, I would strongly recommend install Matlab and bring the laptop if you have any with Matlab installed, so that when I work out the problem on computer, you can replicate the problem on your machines. And as I work out the problem on the computer, I'm gonna copy and paste the stuff onto chat window, so my online students can repeat the exercise and compare the answers in the end. It's not a spectator sport. So if we are going to solve a compressed sensing problem, it's not, you won't get it just by seeing me solving the problem. So unless you work with me step by step to get to the same answer, then you will really understand. We'll actually work out the neural network problems in Matlab. How many of you have used the deep learning toolbox in Matlab? One or two? How many of you have used the reinforcement learning toolbox in Matlab? How many of you have used LSTM, long short-term memory type of network in Matlab? So all these resources are available to you free of cost. Please do not reinvent the wheel. Use this opportunity to make yourself familiar with the tools that are available to you. And then eventually what you can do is, I'm very sure that throughout the curriculum, you're going to take advanced classes in machine learning or vision, or at that time, you can use this information to master the content and learn advanced. So the idea is, at the end of the class, you should be exposed to the concept in linear algebra and the applications of linear algebra. You can use Matlab or any other software to work out the problems. But at the end of the day, just you need to either type or write those answers neatly on piece of paper, scan and upload it as one single file. Oh, assignment, it's very easy. It's a good question. Just taking the course. It's an interactive course, which means as you take the course, they will ask you to create and run Matlab scripts. So you will be asked to create the Matlab program, and then there is something called as the Matlab framework. It will check your code and give you real-time feedback. So you will have to code in Matlab to be successful, to finish these classes successfully. They are not just classes that you just watch and just do nothing. It's an interactive class where you have to interact with Matlab, and that is Matlab web-based. So you can actually work, if you want, you can do the course over the phone or an iPad and actually log into the Matlab web server and yes, they are easy. John has done it. John took my robotics 1, robotics 2 class, but they are time consuming. But you will learn nitty-gritties of Matlab. Okay. And Jesslyn is the grader for this course. Jesslyn. So if you have, she's gonna grade your assignments. So make sure if you have any question, concerns about your grade, you are welcome to talk to her, or you are welcome to stop by my office. My office hours are right after this class. So you can ask me any questions that you may have, and I would be happy to help you out. Okay. Any questions, concerns, ideas, doubts? Man, this room is really hot. Okay. What if you get stuck in a difficult problem in assignment 3? My hope is that if you get stuck in any problem in assignment 3, you would have already worked out the problem partially, and you can ask me intelligent question so that I can guide you in the right direction. Or if you have come so far, then you are welcome to see me and I can help you with the assignment. But you need to do something. And most of the problems, the hints are in the textbook, so you can actually, you will need to do something on the assignment website. So you will need to upload the certificate, or you need to solve the problem, scan your handwritten work and upload in Canvas. So that's what you need to do. Offline office hours be a possibility. Yes, but for that you need to send me an email, and then I will send you a Zoom link and we can have a discussion over Zoom. Okay. Any other questions? Yes. Yes, yes. Actually, ISU has subscribed the institution license, the Matlab license, and all the courses are free of charge. So you just have to download the Matlab software and create a login at MathWorks website. Any questions, concerns? So before I begin, let me ask you, have you had, how do we know the pre-recording to go to get ready for upcoming lectures? Is there any way what needs to be prepared? Okay, if you look at the announcements, if you look at the schedule, so this kind of tells you what we are going to cover in each and every class. Now, as you can see in today's class, I'm going to talk about 4 important concepts. So you are welcome to read the section 1.1 from the textbook, 1.2 from the textbook, 1.3 from the textbook, 1.4 from the textbook. If you want, the video lectures for section 1.1 and 1.2 are already uploaded that talk about that discuss the theory in the textbook in detail. So you are welcome to pace yourself, and I will actually upload some more lectures related to 1.5, 1.6, 1.7 SVD, and if you go to the module, you will see the resources related to some of these materials. So that will help you get prepped for the class. Any other questions?
Some of the assignments would be completed in a group. So are these 7 the only assignments, or will it be added?
No, there are only 7 assignments.
So all of them are individual.
So basically, in this, so you can't do course project. I mean, you cannot do Matlab course in a group. It's an individual certificate. So you have to log into your own account, finish the course. You can't do that in group. When you come to assignment, when you go to assignment 3, if you look at the problems, there are some problems that are super simple that you can do on your own. There are some problems which are difficult and probably need teamwork. you'll get to the answer. At that time, you can work in the group. But don't copy. Try to learn as much as you can, because all this information is going to be super duper important. Okay. If there are no questions, I'm gonna start talking about the material. Any questions from my online students? The video lectures. The video lectures are in module. So if you go to the course Canvas website, if you go to module, there are video lectures already. Any other questions? So from next time, please, if possible, please bring laptop. Yeah. Video section on modules is not visible. Okay. Modules. No, video lectures and notes. They should be visible to you. Now, are they visible? Okay, so if you go to video lectures and notes, there are notes part 1.0, 1.1, and the PowerPoint slides for section 1.1, 1.2, PowerPoint slides for section 1.2. Okay. My online students, can you see the video lectures now? Okay. All right. So I'm going to start talking about linear algebra. So first and foremost, can anyone tell me what is linear algebra? Yeah, go ahead.
I have a question about direction. So when should I work the direction, like before this class or after the class?
It's totally well, it's totally up to you. I mean, my recommendation to you is I will try to upload the lectures before. So for example, what I'm going to teach next week, I plan on uploading the video lectures. This is the first time I'm teaching class. So unlike robotics one, I didn't complete the video lectures already, but I will try to finish those video lectures before the class next Tuesday. So you can actually watch them and come to class prepared. Also, I would strongly recommend that just take a look at the cheat sheet. This is the gist of the entire book. So, and I will, once you understand these basic concepts, believe it or not, you will understand machine learning, artificial intelligence. As a matter of fact, the homogeneous transformations that we are going to study in robotics, solving singular problem in robotics, that will become super simple. And feel free to stop me anytime and ask any questions that you may have. Okay, so I'm gonna start. I have about half an hour. So I'm gonna talk about some super simple stuff. So what do you think about linear algebra? What is linear algebra? Right. So what is your first experience with linear algebra? I'll tell you my first experience with linear algebra. This is the problem I solved when I was in 7th or 8th grade. Okay. I have two apples and maybe a negative orange. Okay, so I have two apples and a negative orange. You know what I mean. Uh, the total cost is 0. So if I buy two apples, but I finish the orange I have, the total cost is 0. If I have minus one apple plus two oranges, the total cost is $3. So this is the classic problem we try to solve when we are in high school. So we have two apples, three oranges, some money, one apple, two oranges. There is some cost. So find the cost of each apple and each orange. That is the problem. That is the very first problem uh, that introduces us to linear algebra. Now, you have studied the fundamental idea behind linear algebra is to get the solution. What is a cost of an apple or what is the cost of an orange? So in other words, solve this linear system of equations. That's why linear algebra. We are trying to solve linear equations. This is what you studied probably in your undergrad. So what we studied that this equation can be solved multiple ways. The easiest way to solve this equation is write this equation as 2 minus 1 minus 1 2 multiplied by x y is equal to 0 3. Do you agree with me? And then probably you saw that when you multiply 2 minus 1 and you expand, this is the equation that you can get. And this equation is of the form ax is equal to b, where x is the unknown, and somehow with all these transformations I need to find out what are the values of x. Now, other thing that these two equations can be solved is graphically. So do you remember the techniques wherein we try to solve the set of equations with graphical technique? What do? We plot the lines, and the point where these two lines intersect is the point that is the solution to those two equations. So let me do that. So what I'm going to do is I'm going to have a y-axis, I'm going to have an x-axis, and I'm going to plot the line. So this one line, and then I'm going to have the second line, and the point where these two lines intersect. So let me show you. These lines are 2x minus y. This line is 2x minus y is equal to 0. And this line is minus x plus 2y is equal to 3. And when I plot these lines, the point where these two lines intersect is the solution. Agreed? Now, here is the question. Think about a situation where these two lines do not intersect at all. So which means maybe you land up with a problem wherein, and this is important, you have a line which is something like this, and you have another line which is something like this. So these two lines don't intersect at all, which means there is no possible solution. In other words, what I would say in this case is number of unknowns, the number of unknowns exceed the number of equations that are available, which means I cannot find unique values for x and y. Now, this is all great. So alternatively, you may say, oh, this is too simple. What I can do is I just take x, I just take y, and so as ax is equal to b, to find x, I can actually invert the matrix, multiply that by b, and actually get the answer. This inverse is something similar to a reciprocal operation in the case of scalars, but this inverse may not be possible for all the cases. And there are certain cases when the inverse is not possible. Now, assuming that you found this intersection, if you plug this number in this equation or this equation, that is going to satisfy left hand side is equal to right hand side. So how do we solve? How do we know that something is the solution of equation? We take that solution, plug it into the expression, and the left hand side equals right hand side. Now, this problem, if I were to add x, y, and z, so think about it like if I were to add three variables, x, y, and z, this problem can be described in a three-dimensional plane. And idea is the same. Plot lines or plot planes in 3 dimension and see where those planes intersect. And the point where these planes intersect is nothing but the solution of those set of linear equations. And all that is great. But there are some problems with this approach. And I'm going to talk about a slightly different way of looking at the same problem. And this is fundamentally a different approach, fundamentally a different way of looking at same set of equations. So before I go there, everyone understood that we have two equations, two unknowns. We can solve them using matrix inversion. We can solve them by plotting, and we can solve them using intersection. Everyone understood this? Second concept, which is trivial, may seem trivial, but I want you to make sure that you understand this. When I'm multiplying matrices, first row gets multiplied with first column. When I multiply first row with first column, I get 2x minus y is equal to 0. When I multiply the second row with the first column, I get minus x 2y is equal to 3. Do you agree with me? This is called as row multiplication because I have these rows and I am multiplying those with column. So this is called as row multiplication. And the picture that I have drawn here is called as row picture. So what it means is I have described to you a simple matrix operation that you must be intimately familiar with, must have done many times. That is nothing but the multiplication of row and columns. Row and columns. This is also sometimes called as inner product. Now what I'm going to do is I'm going to rewrite the same equations from column perspective, and it will be all clear in just a second. So same equations, 2x minus y is equal to 3 minus x plus 2y is equal to 3. So just verify that these are the same equations that we attempted earlier. But now I'm going to rewrite these equations something like these. I'm going to write this equation x 2 minus 1 plus y minus 1 2 is equal to 0 3. And before I proceed further, I want you to look at these equations very carefully and verify that if I expand these equations, if I say this is 2x minus y gives me 0 minus x plus 2y is equal to 3. So I land up with the same equations. Everyone understood this? But this multiplication is column multiplication. So what I have is super important. I have a number. It's a single number, single scalar value. This is just a number. This is not a matrix. This is not a vector. This is just a number multiplied by a column vector. Column vector means the numbers which are arranged in a column fashion, multiplied by another number and a column vector. It is giving me some answer. Do you agree with me? So this is the multiplication using columns. So just like the previous problem, wherein we plotted, when we try to solve it, we plotted this equation. Now I want you to think about how would I plot this? How would I plot the set of equations that we have over here? Vector. Okay, so what I'm going to do is I'm going to do this. This is my argument, and let me present it to you. I'm going to first start with a coordinate system x and y. I'm going to start with a coordinate system x and y, and then I am going to try to plot two vectors. This is important. I'm going to plot two vectors. The first vector is this guy. Now you may say, oh, what do I mean by plotting this vector? So plotting a vector is very simple. So this is 1, this is 2, this is 3. And then I have minus 1, minus 2, I have plus 1, plus 2, and so on. So what I'm going to do is I'm going to try to locate this point 2 minus 1. So this is 2 and this is minus 1. So this is the point 2 minus 1. And then I'm going to draw an arrow starting from the origin. And I'm going to say this guy is my vector. Then I'm going to do the exact same thing for the second system. Minus 1. So this is minus 1. This is the x value, okay? So this is the x value. This is the y value. And then I'm going to do 2. So basically here. So this is the second point. And then I'm going to draw the second vector. So this guy is this. Weird, because these two guys already intersect at 0, 0. So what are we trying to solve it for, right? Now, what I'm going to do is, here some of the magic happens. So what I'm going to do is, I'm going to draw the last vector 0, 3 in such a way. So if I want to draw this last vector 0, 3 in such a way that the linear combination, so basically this vector plus this vector somehow gives me the final answer, which is 0 multiplied by 3. So what I'm going to do is, I'm going to scale this vector. I'm going to scale this vector, the first vector, by a constant. I'm going to scale this vector by a constant. I'm going to scale this another vector by this constant y, and somehow try to come up with a value which goes through 0 and 3. And some of you may say that doesn't make sense at all. But see, here is the point. What I want you to do is, I want you to think about this resultant. So I want you to think about the linear combination of these two vectors. So I have one, and then I have one more. So what I'm going to do is, I'm going to shrink this vector 0, 1 by a constant x, and this constant is a number. I'm going to shrink this by x. I'm going to shrink or expand this guy by y to such an extent that finally, all things said and done, I'll land up with the vector 0, 3. So if I were to look at the vector 0, 3, this is the vector. So this is the vector 0, 3. Now, this may be a little bit difficult to visualize, but here is the idea. So somehow expand or shrink this vector. Somehow expand or shrink this vector and add this vector to that expanded or shrunken vector, so that finally you get the resultant vector 0, 3. Now I totally get it. This is super duper difficult to visualize. And the reason it is difficult to visualize, the most important is because this vector, which is 2 minus 1, and the other vector, they are not perpendicular to each other. That is the reason why it is difficult for us to resolve these vectors to obtain the correct result. But believe it, it is possible. You can, if you were to try, what you can do is, if you were to try using some sort of geometry software, you can actually shrink and expand. The only condition is this. What I want you to do is, you should shrink or expand this vector, shrink or expand this vector. What it means is, you can either stretch this line or shrink this line, or flip this line, which means then the vector will have a negative value. So you can stretch or shrink this line so that at the end, the resultant is 0, 3. And then the weights on these two vectors, and these weights could be positive or could be negative. So once you have those, we found those weights x and y. X and y is a scalar. That is absolutely correct. X and y is a scalar that can take values such as 0, some either a negative value or a positive value. So what would happen then? There will be a number here. There will be a number here, and when I plug that number in here, the first equation, this equation, will get satisfied, and simultaneously the second equation will get satisfied. Everybody understood this? Yes. So if you shrink it, if you shrink it, it's a fraction. If you extend it, it's 1, 2, 3, 4. If you shrink it, but if you multiply that by a positive number, that is going to be in the same direction. If you multiply that by a negative number, it means you flip the direction of the vector. So basically, x can take value like -2, -3, -0.5, +0.5, 1, 2, 3, 4, whatever. But at the end of the day, the answer that you are going to get is going to be the exact same answer. Yes, once you are adding them, why do them? Don't you draw the tail? That is absolutely correct. But the way I have drawn the vectors, if I were to subtract them, then I would do tail to tail. And when a subtraction is nothing but negative addition. So that actually would completely make sense. So at the end of the day, you want to find out those weights, positive, 0, or negative, so that the linear combination is linear. Why is combination? Because you have 2 or more together. The linear combination presents the result. That is the fundamental concept in solving linear equations. If you look at the column space, to find the solution, these two vectors should be linearly independent. What it means is you should, the information that one vector provides should not be the same as the second vector. What I mean by that is, let me give you an idea. This vector, rather than being in this direction, it's in the same direction here. You agree with me, no matter what weights you have, 1, 2, 10, 50, 100, 1000, infinity, no matter what you do it, you are never gonna get this value. So imagine what this means is, if the vectors are not independent, the system of equation cannot be solved. Now some of you may ask me, this is super confusing. And yes, this is confusing. And why this is confusing? The reason it is confusing, because these basis vectors, so this I'm going to call V1, I'm going to call this V2, V1 and V2, they are called as the basis vectors. Now, this is the point. What it means is, I want you to think about the span. What do I mean by span? Span is nothing but, if I were to construct a plane, we need two vectors to show a plane. So if I were to construct the plane that is spanned by these vectors, this is the plane. This is the plane that is spanned by two vectors. As long as this resultant vector, which is 0, 3, is on that span, you have the solution. Does it make sense? As long as this resultant vector. So here is what I'm trying to do. I have these two basis vectors, and vectors, as we know, can expand or shrink. So basically, what I'm going to do is I'm going to use these two vectors and create a plane. As long as my final resultant is on that plane, the solution is possible. So in other words, this is on the span. So I'm going to B is on the plane constructed from V1 and V2. Now let me give you a hypothetical situation. Imagine I have this B for some reason on a plane which is perpendicular to these two basis vectors. If that value of B is somewhere perpendicular to the basis vectors, no matter what you do, you are not going to solve the problem. In other words, how much you extend in X, how much you extend in Y, you will never be able to get to a point that is on Z. Let me see that once again, because that's important. If there is a point on Z, X, Y, and Z, if you need to go to point on Z, you need a unit vector in Z direction. No matter how far you go in X direction, no matter how far you go in Y direction, you will never get to point on Z. In other words, that is the null space of that vector basis, which means you cannot get to that point. It's a null space. And that is the fundamental concept behind the four important subspecies. What are these four important subspecies? Now I will show you in just a second. First, we talked about the row space. Second, this is called as the column space. This is called as column picture. So you have something called as the row space, and this product is called as outer product. And outer product is the fundamental part when we look at the matrix decomposition as singular value decomposition, QR decomposition, LU decomposition. So there are four fundamental subspecies. And there is row space, there is column space, there is a null space associated with row space, and there is a column space, the null space associated with the column space. And I will talk about these in detail in my next lesson, but just to give you hints, there is something called as, if you have the matrix A, you are going to have the row space, of A. There is something called as the column space of A. So this is shown as basically C of A, actually, and then there is C of A transpose, but we'll talk about that in little late. So row space approach is used in URV type of decomposition, which is LU, QR, SVD, and then you have L, Q, and U. So this is used in the input basis. and this is used in the output basis. The basis. Now, a key concept which I want to talk about is again what I said about the linear independence. So I'm going to explain that with a problem. I have 2 apples plus 5 oranges for $10. And now say I have 4 apples plus 10 oranges for $20. Now my question to you is, can you solve this problem? You cannot solve this problem because if you think about the first equation is the copy of the second equation. Now, in other words, believe it or not, if you plot or if you have this matrix 2, 4, 5, 10, this has only one independent row, which is equal to one independent column. And can someone tell me what I'm going to say next? This matrix has rank is equal to 1. So this is a rank deficient matrix. What this tells me that I have 2 unknowns and 1 equation. So I cannot solve this problem. In other words, if I even attempt using Matlab or something else to try to solve this problem, I cannot find the inverse of this A. A is not invertible. A step further, if I were to look at the column picture A, and you will see this in just a bit, and then I will stop you. Plus orange 5, 10 is equal to 10, 20. Can you see it? The first vector is 2, 4. First vector x is equal to 2, y is equal to 4. Second vector 5, 10, go to 5, go to 10. So both these vectors are on top of each other, which means the span of these 2 vectors is 0. You don't have a span. They are in the same line, so they don't span. So any point that is not on that span, any point. So what if you have point over here? If you have point over here, you cannot travel in x direction and get to a point which is in y direction. Or you cannot travel, you can travel as much as you want in x, but you are not going to go to a point which is given by x comma y, unless that y is 0. And that's what it means, that these basis vectors, so the basis vectors, the span from these basis vectors, and that is where we'll stop today. So these are the important concepts from the section 1, 1.1, 1.2, 1.3, and 1.4, and I will work out the problem. The number of rank is equal to the number of independent vectors. Row vectors is equal to column vectors. So I'm going to stop here, and I would be happy to answer